This video will be about adding and subtracting rational functions.
I'm sorry, say it again.
So, one of the easiest kinds are if the denominators are the same already.
Oh, excellent.
When your denominator is the same, we're good to go. We can add our fractions already, but you only add the top parts. The 5 plus 9 will add to be 14. The bottom you leave as c minus 5. It is the same for every single fraction. What can change things is if the denominator is different. Say we have 7 over 3a plus 2 over 5. If the denominator is different, we would like to get a common denominator. So we need to figure out what do we have to multiply this 3a by, and what do we have to multiply this 5 by. So usually our easiest way is to just multiply them by each other. I'm going to multiply the 3a times the 5, but with fractions are kind of like equations where what you do to one thing you have to do to the other. Usually it's what you do to the left side you have to do to the right on an equation. On a fraction it's what you do to the bottom you have to do to the top. So then on the other fraction, we're going to multiply by the 3a. So we do that multiplication now. 5 times 7 is 35. 5 times 3a is 15a. 2 times 3a is 6a. 5 times 3a is 15a. So now that our denominators match, they are both 15a, we can reduce our fraction, or I should have said add our fraction. That's a better term than reduce at this point. So again, we just are only adding the top pieces. The only problem is 35 plus 6a, those are not like terms. They cannot actually combine together. But because we want this to be one fraction instead of two, we're going to put one fraction line underneath them. And again, we only use the 15a once on the bottom. We don't add the 15a and the 15a. We leave the bottom alone. Now in a problem like this, you do need to check and see if there's something that you can reduce by. So starting with this top stuff, I want to see, is there anything that divides into both 35 and into 6? Well, 35 is like 1 times 35 or 7 times 5. 6 is 1 times 6 or 2 times 3. The only thing they have in common is a 1, which we can ignore. Doesn't help us. So if there's nothing that divides into it, we can't reduce this any further. They can make this a little bit more difficult by putting two different things in the denominator. So let's say we have c over c plus 5 plus 4 over c plus 3. So now the bottoms are kind of weird looking. We have c plus 3, c plus 5 on the bottoms. But we still follow the same idea. I'm still going to multiply the other fraction, so in this case the second fraction, by the denominator of the first, by c plus 5. Now since this is bigger than normal, we have this plus sign, we're going to put it in parentheses. Because when we multiply this 4, we're going to have to multiply it in using distribution. The c plus 3, we'd multiply by the first fraction. Again, we'd have to multiply it out using distribution. So c times c is c squared. C times 3 is 3c. A lot of the times, they will not even multiply the bottom part out again. They'll leave it as c plus 3 times c plus 5.
Hi, Derek. This is Andrea Jamie. I'm your school counselor at Graduation Alliance.
Over here, we distribute our 4 in. We have 4c plus 20. We get c plus 3 times c plus 5 on the bottom still. Now we can add any like terms on the top. There is only one set of like terms right now, and that's 3c and 4c. They both have the letter c, The reason c squared is not included is because it has the exponent of 2. So we would have c squared plus 3c plus 4c is 7c plus 20, and we leave the bottom alone, c plus 3 times c plus 5. Now again, we need to check and see if this would reduce. So now, where we have 3 things here, to factor this out, before we just had to think, oh, what divides into each? To see if this factors, we need to check numbers that multiply to be 20 and see if any of those numbers would also add to be 7. So 20 is 1 times 20. If I add them together, I get, oops, sorry, I wrote the answer down. I get 21. Those didn't work. So we try something else. 2 times 10. 2 plus 10 is 12. That didn't work. 3 doesn't go into 20. 4 does. 4 times 5. 4 plus 5 is 9. That didn't work. If I go to my next one, 5. 5 times 4. Well, we've already done 4 times 5. 5 times 4 would be the same thing. So the top part does not factor, which means we can't reduce any further. So hopefully this will help you with rational, adding and subtracting rational expressions.